Welcome to our exploration of the nature of environments. In the artificial intelligence and robotics world, understanding the environment in which agents operate is crucial for designing intelligent agents. Environments can vary widely in complexity and characteristics. They can be static or dynamic, observable or partially observable, and discrete or continuous. Let's break this down. In designing an agent, it is important to specify the task environment. This includes four key components. Performance measure. This defines how we evaluate the success of the agent. It sets the criteria for determining if the agent is performing well. The second one is external environment. This is everything the agent interacts with. Understanding the environment helps us design the agent's responses effectively. Actuators are the parts that allow the agent to take action, such as motors or robotic limbs. And finally, sensors. Sensors collect information about the environment, enabling the agent to make informed decisions. There are different types of environments available. Let us see one by one. Fully observable environment with partially observable environment. Fully observable environments. Agents have to complete access to the state of the environment at all times. In these sensors detect all relevant aspects needed for decision making. Partially observable environments. Agents do not have complete access to the state. Information may be limited due to noisy or inaccurate sensors, missing data. For example, a vacuum cleaner with a local DAT sensor cannot detect that in other areas. An automated taxi cannot predict other drivers' intentions. Understanding the level of the observability helps in designing agents that can effectively navigate and make decisions in their environments. The next one is single agent is multi-agent. The single agents involves only one agent operating independently. For example, an agent solving a crossword puzzle by itself. Multi-agent environments involves two or more agents interacting with each other. The example, an agent playing chess where it competes against another agent. The distinction between single agent and multi-agent environments helps defining the complexity of interactions and strategies required for the agent's decision making. Deterministic is stochastic. The next state of the environment is completely determined by the current state and the agent's action. For example, image analysis. The outcome is predictable based on the input image and processing steps. In stochastic environments, the next state of the environment is not entirely predictable and can involve randomness. For example, car driving, the factors like traffic, weather, and other drivers introduce uncertainty in outcomes. Understanding whether an environment is deterministic or stochastic influences how agents make decisions and plan their actions. In episodic environment, the agent's experience is divided into discrete, independent episodes. Each episode, the agent receives a percept and performance a single action. The outcome of one episode does not affect the next. For example, blood testing for patients. Each test is a separate episode with no influence from previous tests. In sequential environments, current decision can impact all future decisions. Agents must consider the long-term consequences of their actions. For example, chess and taxi driving. In chess, each move influences their remaining options and strategies throughout the game. In taxi driving, short-term decisions like a route selection can affect overall travel time and passenger satisfaction. In static environment, the environment remains unchanged while the agent is making decision. The agent does not need to continuously observe the environment during deliberation. For example, crossword puzzles, the state of the puzzles does not change while the agent is solving it. In dynamic environments, continuously present the agent with decision to make. If the agent has not made a decision, it is effectively choosing to do nothing. For example, taxi driving, both the taxi and the surrounding vehicles are in constant motion. If the driving algorithm hesitates or takes time to decide, it can lead to potential issues due to the changing environment. In the case of discrete environments, the environment has a finite number of distinct states, percepts, and actions. For example, chess features a limited number of positions and moves, making it a discrete environment. In continuous environments, the environment has an infinite range of states and actions that can change smoothly over time. For example, taxi driving, the speed and the location of the taxi and other vehicles vary continuously, representing a continuous state and a continuous time problem. Known with unknown environment. In known environment, the outcomes for all possible actions are predetermined and understood by the agent. For example, solitaire card games. The rules and the potential outcomes are known, but the agent cannot see the cards that have not been turned over, introducing uncertainty. In unknown environments, the outcomes of actions are not fully understood, even if the environment is fully observable. For example, new video game, the screen display the entire game state, but the agent does not know the functions of the buttons until it experiments with them. The figure lists the properties of several familiar environments. These properties help categorize and analyze environments, aiding in the design and development of intelligent agents. Thank you for watching.